Welcome to the ambiguous case for the law of sines. You know it's not ambiguous? My thirst for justice.
Let's first quickly review the law of sines that says the ratio of the length of a side of a triangle to the sine of the angle opposite that side is the same for all sides and angles in a given triangle. So what this is saying is that the ratio of a given side length in this triangle to the sine of the angle opposite that given side is going to be the same for all sides and angles in this triangle. So what we know is that the sine of angle A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over C. That is what the law of sines says. Now we're also going to review the three different methods for finding a missing side or angle in a triangle. The first would be to use one of your trig ratios in SOHCAHTOA, sine, cosine, or tangent. And that's only going to be useful if you have a right triangle and you're given either two side lengths or a side and an angle. Also, don't forget, if you're trying to find the missing side of a right triangle and you're given the other two sides, you can always use the Pythagorean theorem too. If it's a non-right triangle, you're either going to use the law of sines or the law of cosines. Now the law of sines comes into handy when you're given two angle measures and the length of one of the sides, or you're given two side lengths and the angle measure opposite one of those given side lengths. That's when you use the law of sines. The law of cosines comes into handy when you're given two side lengths and the included angle measure of one triangle, the angle between those two given sides, or if you're given all three sides in a triangle. Now today we're going to be focusing on one situation in particular when you're given two sides and an angle opposite one of those sides. When this happens, there's actually a set of circumstances where you could create two possible triangles with the given information, with the given two side lengths and the angle opposite one of those side lengths. And we'll show you now how that works. So this is called the ambiguous case for the law of sines. It says when given two sides and an angle opposite one of those sides, if a side opposite the given angle is greater than the height and less than the adjacent side, two possible triangles may be formed. So typically what happens is you're going to be given an angle, a side length adjacent to that angle, and a side length opposite that given angle. And the side opposite your given angle is going to be greater than the side length adjacent to your given angle. And when that happens, only one possible triangle can be formed. But there's a particular set of circumstances, like we said before, where two possible triangles can be formed. And that is when you are given an acute angle measure and the height of your given triangle is less than the side length opposite your given acute angle, which is less than the side length adjacent to your given angle. When that happens, two possible triangles can be formed. And you're thinking, how can that be possible? Well, because the height is less than the length of the side opposite the angle, which is less than the length of the side adjacent to the angle, what we can actually do here is take this opposite side length and swing it to the other side of the height, thereby creating a new triangle, an obtuse triangle over here, that has the exact same given measurements as the triangle that we had before. It has the exact same angle measure, the exact same opposite side length, the exact same adjacent side length, and the exact same height. The only difference is now it's an obtuse triangle rather than an acute triangle. This is actually the reason there was no angle side-side congruence postulate when we were proving triangles congruent. You can take this given information and create two separate non-congruent triangles. Now let's talk about how many triangles are possible. So today you're going to be given a certain amount of information. You're going to be given two side lengths and an angle opposite one of those side lengths. And you're going to be tasked with determining, will this given information produce 0, 1, or 2 possible triangles? Well, this is the chart you're going to use to figure that out. The first thing you're going to do is look at your given angle measure because you're going to be given one angle. If that given angle measure is acute, then you will be able to form either 0, 1, or 2 possible triangles with that given information. So you need to look a little closer at what you're given. If the length of the side opposite your given angle is less than the height, 0 possible triangles can be formed. If the length of the side opposite your given angle is greater than the length of the side adjacent to your given angle, or if the length of the opposite side is equal to the height, in this case making it a right triangle, then one possible triangle can be formed. And if the height is less than the length of the side opposite your given angle, which is less than the length of the side adjacent to your given angle, that's when the ambiguous case occurs. That's when two possible triangles can be formed. If your given angle measure is obtuse, it's kind of nice because only 0 or 1 possible triangles can be formed. And you're just going to look at the length of the side opposite your given angle and the length of the side adjacent to your given angle. If the length of the side opposite your given angle is less than the length of the side adjacent to your given angle, that's when 0 possible triangles can be formed. If the length of the side opposite your given angle is greater than the length of the side adjacent to your given angle, that's when one possible triangle can be formed. And this right here makes sense because if you have an obtuse angle, it's going to be the biggest angle in your triangle, meaning the side opposite has to be the biggest side in your triangle. So if it's not, that's when 0 possible triangles can be formed. If it is, then one possible triangle can be formed.
All done fighting crime. It's example time.
Now example 1 says given triangle ABC, determine the number of possible triangles that can be formed with the given measurements. Draw a sketch of each possible triangle. So again, we are given an angle measure and 2 side lengths. The first thing you need to do is make a sketch. Now to start your sketch, you need to create your angle first. We're going to call it our anchor angle, and we're going to draw it on the left side of our page here. So I'm going to create a 110-degree angle and call that angle A. Next, I'm going to label my adjacent side length, and I'm always going to put it to the left of my anchor angle. Now, which of these segments is going to be my adjacent side length? Well, it should have A in it because this segment right here, one of the endpoints is A. So which of these segments has A as one of the endpoints? That would be segment AB. So I'm going to put segment AB over here and label it as 19 centimeters. Next, I'm going to complete my triangle by drawing this side length over here, and we know if this point is A, this point is B, then this point over here must be C. Therefore, segment BC we can now label as 32 centimeters. Now we've successfully made a sketch of our triangle so we can get to answering this question. The first thing you're going to do is figure out, are you given an acute angle measure or an obtuse angle measure? Well, here it looks like our anchor angle is 110 degrees, meaning we are given an obtuse angle measure. Because of that, we look at our chart and we see we just have to figure out, is our opposite side length less than or greater than our adjacent side length? Well, in this particular instance, our opposite side length is greater than our adjacent side length. And when that happens, one possible triangle can be formed with these given measurements. And we're done. Part B, we're doing the same thing. We're given an angle measure and 2 side lengths. So the first thing we need to do is make a sketch of this triangle. Now, when we are making our sketch, the first thing we should sketch is our anchor angle, the given angle measure. So we're going to sketch a 61-degree angle and call that angle B. Next, I'm going to label my adjacent side length, and it's always going to be the side to the left of our given anchor angle. So it's going to be this segment right here. So is this going to be segment BC or segment AC? Well, it should include B as one of the endpoints, meaning segment BC will be our adjacent side length, so I can label that 35 miles. I then can complete my triangle by drawing this segment over here, and since this point is B, this point is C, this point over here must be A, meaning I can label segment AC as 32 miles. Now that I've successfully made a sketch of this triangle, I can look at my chart and figure out, will this given information produce 0, 1, or 2 possible triangles? Well, the first thing I need to look at is my anchor angle, my given angle measure. And what is the measure of that angle? Well, my anchor angle is 61 degrees. That's an acute angle. Because of that, this given information could produce 0, 1, or 2 possible triangles. In order to figure that out, I need to compare the height of this given triangle, the length of the side opposite our given angle, and the length of the side adjacent to our given angle. So I clearly need to find the height of this triangle. So how do I find the height of this triangle? Well, as you can see, when I drop this height, this altitude right here, I actually create a smaller right triangle over here. Now, if we're just looking at this little right triangle right here, I have an angle measure. I'm trying to find the length of the side opposite that given angle, this height right here, and I am given the hypotenuse, the side opposite our 9-degree angle. So I can use a trig ratio in order to figure out the height here. So what trig ratio involves opposite over hypotenuse? That would be sine. So I'm going to say sine of my given angle is equal to the length of the side opposite our given angle over the length of the hypotenuse. Now I can solve for the height, solve for h by plugging in what I know. I know the angle measure is 61 degrees. That goes in here. I know the measure of segment BC is 35 miles. That's going to go in here. Now I can solve for the height by multiplying both sides by 35, plugging this in my calculator, and I get that the height of my triangle is approximately 30.6 miles. Now that I know the height, the length of the side opposite my given angle, and the length of the side adjacent to my given angle, I can write an inequality comparing those measures. And I see that the height of my triangle is less than the length of the side opposite my given angle, which is less than the length of the side adjacent to my given angle, meaning 2 possible triangles could be formed with these given measurements. Now the question wants us to draw a sketch of each possible triangle. So I need to sketch the other possible triangle here. So I again am going to have my anchor angle as 61 degrees. So I'm going to draw a 61-degree angle. My adjacent side length is still going to be segment BC, and it's still going to be 35 miles. My opposite side length is still going to be segment AC, and it's still going to have a measure of 32 miles. My height is still going to be 30.6 miles. The only difference is I'm going to take this opposite side and swing it to the other other side of my height over here and create an obtuse triangle with the exact same given measurements. These would then be the two possible triangles that can be formed with these given measurements.
I'm busy fighting. You try.
Okay, doing the same thing. I am again given an angle measure and two side lengths and tasked with determining how many possible triangles can be formed with these given measurements. So remember, the first thing I have to do is make a sketch. And in my sketch, the first thing I'm going to draw is my anchor angle, my given angle measure. So I'm going to create an angle with a measure of 57 degrees down here and call it angle D. Next, I'm going to label my adjacent side length, and it's always going to be the side to the left of my anchor angle. So it's going to be this segment right here. Now, which of these segments is going to be my adjacent side? Well, it must include D as one of the endpoints. So which of these segments includes D as one of the endpoints? That would be this segment right here, segment DE. So I'm going to label segment DE right here as 27 meters. Next, I'm going to finish this triangle by drawing this side length over here. And since this point is D, this point is E, that means this other point must be F, thereby making this segment EF. So I can label that as 25 meters. So we have successfully made a sketch of our triangle with this given information. Now we need to actually answer the question. We need to determine the number of possible triangles that can be formed with these given measurements. So how do we do that? Well, we look at our chart and we see the first thing we have to determine is, are we given an acute angle or an obtuse angle? Well, our given angle here, measure of angle D, is 57 degrees. That's less than 90. So that's going to be an acute angle measure. Because of that, either 0, 1, or 2 possible triangles can be formed. So to determine which it is, I need to compare the height of this given triangle, the length of the side opposite our given angle, and the length of the side adjacent to our given angle. So we clearly need to find the height of this triangle. How do we find the height of this triangle? Well, remember, when I drop this height down here, I actually have created a little right triangle over here, meaning I can use trig in order to figure out the height of the triangle. So if we're looking at this little tiny right triangle here, I am given this angle measure. I'm trying to find the length of the side opposite that given angle, this height right here, and I'm given the length of the hypotenuse, the side opposite our 90-degree angle. So which trig ratio involves opposite over hypotenuse? That would be sine. So I'm going to say sine of our given angle is equal to length of the side opposite our given angle over the length of our hypotenuse. Now all we have to do is plug in what we know. We know the measure of angle D is 57 degrees. That's going to go in here. The measure of segment DE is 27 meters. That's going to go in here. Now all we have to do is solve for the height. So how do we get the height by itself? We multiply both sides by 27. Plug this in our calculator, and we get that the height of our triangle is approximately equal to 22.6 meters. Now that we found the height of our triangle, the length of the side opposite our given angle, and the length of the side adjacent to our given angle, we can write an inequality comparing those values. And we see that the height of our triangle is less than the length of the side opposite our given angle, which is less than the length of the side adjacent to our given angle. And when that occurs, we know that there are two possible triangles that can be formed with this given information. So now we need to move on to the second part of the question, which is to draw a sketch of each possible triangle. We drew a sketch of one of the possible triangles using these given measurements, but we need the second possible triangle. So we start our sketch by creating our anchor angle, the measure of angle D, which is 57 degrees. So we're going to draw a 57-degree angle right here, call that angle D. Now, the cool thing about this is that our adjacent side is still going to be segment DE. Our height is still going to be 22.6 meters. Our opposite side is still going to be segment EF. The only difference is we're going to take this segment over here and swing it to the other side of our height, creating an obtuse triangle with the exact same measurements. These would then be the two triangles that could be formed using these given measurements. Part B, doing the exact same thing. So the first thing we need to do is make a sketch of this triangle with this given angle measure and these two side lengths. So we start with our given angle, which we call our anchor angle. So we're going to create an angle measuring 64 degrees and call that angle D. Now we need to label the side adjacent to that given angle. Remember, we're always going to choose the side to the left of our given angle. So that would be this segment right here. So which of these segments then would be our adjacent side length? Well, remember, it needs to have D as one of the endpoints. So which of these has D as an endpoint? That would be segment DE. So we're going to label this side length as segment DE. That would be 34 yards. Now all I have to do is complete this triangle. So we just need to draw a segment connecting these 2 points. And since this point is D and this point is E, that means this point over here must be F. Therefore, this segment right here must be segment EF, which we can label as 9 yards. Now that we've made our sketch, we can finally go on to answering our question, which is how many possible triangles can be formed with these given measurements. So the first thing we look at is our given angle measure. And here you see that our angle measure is acute. Because our given angle measure DeLazzer, our anchor angle is acute. That means that this given information could produce 0, 1, or 2 possible triangles. Now, to determine which it is, we have to figure out how the height of this triangle, the length of the side opposite our given angle, and the length of the side adjacent to our given angle compare. So, to do this, we first obviously need to figure out what is the height of this triangle. Well, remember, when we drop our height down here, our altitude, we actually create a small right triangle. And in this small right triangle, we are given one of the acute angle measures. We are trying to find the length of the side opposite our given acute angle, and we are given the side opposite our 90-degree angle, our hypotenuse. So, in order to find our missing height right here, we could actually set up a trig ratio to solve for h. So how would we set up a trig ratio? Well, what trig ratio involves opposite over hypotenuse? That would be sine. So we're going to say sine of our given angle, angle D, is equal to the length of the side opposite, angle D, which would be the height in this case, over the length of our hypotenuse, which would be segment DE. Now all we have to do is plug in what we know. We know the measure of angle D is 64 degrees, that goes in there, and the measure of segment DE is 34 yards, so that's going to go in there. Then we just have to solve for our height. Plug this in our calculator, and we get the height of this triangle. Now that we found the height of this triangle, the length of the side opposite our given angle, and the length of the side adjacent to our given angle, we can set up an inequality comparing those measures. And we see that the length of the side opposite our given angle is less than the height of the triangle. And when that occurs, you know that there are 0 possible triangles that can be formed with these given measurements. And this makes sense the more you look at these measurements. If this figure were drawn to scale, segment EF would be too short to reach down to connect with segment DF. So you wouldn't be able to form a triangle here. Now example 2 says solve each triangle, round your answers to the nearest tenth. So we are again given an angle measure and 2 side lengths, but this time we're asked to solve the given triangle. And when a question asks you to solve a triangle, it just wants you to find all of the angle measures and all of the side lengths. So when you are just given measurements and you're asked to solve a triangle, the very first thing you should always do is make a sketch of that triangle. So we're going to make a sketch just like we were doing. We're going to start with our given angle, our anchor angle, and we're going to create a 54-degree angle over here and call that angle A. Next, we're going to label our adjacent side length. And remember, our adjacent side length is always going to be the side to the left or above our given angle right here. So this is going to be our adjacent side length. So which of these is going to be our adjacent side length? Well, remember, it needs to have A as one of the endpoints. So which of these segments has A as an endpoint? That would be segment AB. So I'm going to label our adjacent side length over here as segment AB, 24 kilometers. Now all I have to do is complete this triangle. So I'm going to draw a line segment connecting these 2 points right here. And since this point is A, this point is B, that means this point down here must be C. Therefore, this segment right here, our opposite side length, must be segment BC. I can label that with 23 kilometers. Now that I've successfully labeled this given triangle over here, I see that I have an angle, I have the side adjacent to that angle, and I have the side opposite that given angle. Because of that, I have to determine how many possible triangles can be formed with these given measurements. So how do I determine that? Well, remember, I need to first look at the angle measure that I'm given. Is it acute, right, or obtuse? Well, in this particular example, it looks like we are given an acute angle measure. Because of that, we could have 0, 1, or 2 possible triangles formed with these given measurements. To determine which it is, we just have to compare the height of the triangle, the length of the side opposite the given angle, and the length of the side adjacent to our given angle. So we obviously need to find the height of this triangle. How do we find the height of this triangle? Well, again, we see that we have created this small right triangle here, where we are given one of the acute angle measures. We're trying to find the length of the side opposite that given angle, and we are given the side opposite our 90-degree angle, our hypotenuse. So we can set up a trig ratio in order to solve for our height. So which trig ratio involves opposite over hypotenuse? That would be sine. So we're going to say sine of our angle A is equal to the length of the side opposite our given angle, which is the height in this case, over the length of our hypotenuse, which would be the measure of segment AB. Now I just plug in what I know. I know the measure of angle A is 54 degrees. That's going to go in here. I know the measure of segment AB is 24 kilometers. That's going to go in here. Now I just solve for h, my height. How do I solve for h? I multiply both sides by 24, plug this in my calculator, and I get that the height of this triangle is approximately equal to 19.4 kilometers. Now that I've found the height of the triangle, the length of the side opposite our given angle, and the length of the side adjacent to our given angle, I can put all of those in inequalities and compare their measurements. And it looks like the height of our triangle is less than the length of the side opposite our given angle, which is less than the length of the side adjacent adjacent to our given angle. And when that happens, we see in our chart that two possible triangles can be formed with these given measurements. Because of that, I'm going to have to find the two missing angle measures, the measure of angle B and the measure of angle C, and the missing side length over here, the measure of segment AC, for both possible triangles. So let's start by finding those missing measurements for this acute triangle over here, our first triangle. So which measurement do we want to find first? Well, we can choose from the measure of angle B, the measure of angle C, and the measure of segment AC. Well, since I am given the measure of angle A and the length of the side opposite, and I'm given the length of the side opposite angle C, what I could do is solve for the measure of angle C using the law of sines. And remember, the law of sines is just the sine of an angle over the side opposite is equal to the sine of another angle over the side opposite that angle. And the way I set this up is in my first ratio, I want to make sure that I'm both given the angle measure and the side opposite. So the way I'm going to do it in my first ratio is going to be the sine of angle A over the side opposite, the measure of segment BC, because I'm given both of those measures. In my other ratio, I need to make sure to include what I'm trying to find. I'm trying to find the measure of angle C, so I need sine of C over the side opposite, the measure of segment AB. Now I plug in what I know each of those values are. The measure of angle A is 54 degrees, that goes in here. The measure of segment BC is 23 kilometers, that goes in here. The measure of segment AB is 24 kilometers, that goes in here. And C just stays C, because that's what we're trying to find. Now I just have a proportion that I need to solve for C. So how do I solve a proportion? I use the cross product property. I'm going to multiply across, set the two products equal to each other, and solve for C. So how do I solve for C? Well, I need to get rid of this 23 first. So I'm going to divide both sides by 23, and I get that sine of C is equal to this over here. Now, I need to get rid of sine. That's how I get C by itself. So how do I get rid of sine? Well, the same way I get rid of any trig function. I take the inverse of that trig function on both sides. So I'm going to take the inverse sine of both sides of the equation. On this side, when I take the inverse sine of sine, those two things cancel each other out. That's why I did it, and I'm just left with C. On this side, I just plug this in my calculator. The inverse sine of 24 sine of 54 over 23, press enter, and I get that the measure of angle C is approximately equal to 57.6 degrees. So I can go up here for the measure of angle C, plug in 57.6 degrees, and I found that angle. Now, in order to solve this triangle, I also need to find the measure of angle B and the measure of segment AC. So which one should I solve for first? Well, since I already know two of the angle measures, it'd be pretty easy to find the third angle measure, so let's find the measure of angle B. According to the triangle angle sum theorem, the sum of the interior angles of a triangle must be 180 degrees. So I'm going to create an equation where I add up all the interior angle measures of this triangle and set it equal to 180 degrees. Now I just plug in what I know. I know the measure of angle A is 54 degrees. I plug that in there. I know the measure of angle C is 57.6 degrees. That goes in there. And the measure of angle B, that's what we're solving for. So let's solve for the measure of angle B. We just add these two together right here, subtract that to the other side, and we get that the measure of angle B would have to approximately be 68.4 degrees. So we plug that in up here. Last but not least, we need to find the measure of segment AC. So how do we find the measure of this segment? Again, we can use the law of sines because we are given multiple angle measures and we have two side lengths. So we can use the law of sines. So how do we set up our law of sines? Remember, law of sines is sine of an angle over the side opposite is equal to sine of another angle over the side opposite that angle. Well, in my first ratio, I want to make sure that I'm given both the angle measure and the side opposite. So I'm going to do the sine of angle A over the length of the side opposite, the measure of segment BC, because I'm given both of those measures. And in my second ratio, I need to make sure I include the measure of segment AC. So it's going to be sine of angle B up here over the length of the side opposite, which is the measure of segment AC. That's why we did it. Now I plug in what I know. I know the measure of angle A is 54 degrees. That goes in here. I know the measure of segment BC is 23 kilometers. That goes in here. I know the measure of angle B is 68.4 degrees. That goes in there. And the measure of segment AC is what we're solving for. Now I have a proportion that I need to solve for the measure of segment AC. How do I solve a proportion? I use the cross product property. I'm going to cross multiply, set the two products equal to one another, and solve for the measure of segment AC. So how do I get the measure of segment AC by itself? I just divide both sides by sine of 54. And when I do that, I plug this in my calculator over here, and I get that the measure of segment AC has to approximately be equal to 26.4 kilometers. So that would be the measure of this segment down here. Now, because I have found all three of these measures, I now know all these sides and all of the angles in this particular triangle. So I have solved this triangle. But, as we said before, there are two possible triangles that can be formed with these given measurements. So we're going to take this first answer, leave it up here, and now we need to find the measurements for our second triangle. So let's sketch our second triangle over here. Remember, what you're going to do is you're going to take the length of the side opposite your given angle, angle A, because that's what we were given at the beginning of the problem. We're going to take that side and we're going to swing it to the other side of our height. So it's going to look something like this. Now, before we get rid of this stuff, we can actually use the angle C that we found at the beginning plugin to help us find this new angle right here in our new triangle. Because when we swing this side over here, we create an isosceles triangle. That means that this angle right here, the angle C that we found in our first triangle, has to be congruent to this angle right here. So if this is 57.6 degrees, the measure of this angle also has to be 57.6 degrees. And now you see that these two angles actually form a linear pair, meaning they are supplementary. So I can take 180 degrees, subtract out 57.6 degrees, and I'm left with the new measure of angle C in my new triangle, which is 122.4 degrees. Again, I'm solving this triangle, so I need to find the measure of angle B and the measure of segment AC. And as we said before, we should find the measure of angle B first, because we already have two of the interior angle measures. And we know that by the triangle angle sum theorem, the sum of the interior angles of a triangle must be 180 degrees. So we add up the measures of each of the interior angles in this triangle, set it equal to 180, and solve for the measure of angle B. So I'm going to plug in 54 degrees for the measure of angle A. I'm going to plug in 122.4 degrees for the measure of angle C now. And now we can solve for the new measure of angle B. So I add these two together, subtract that to the other side, and I get that the measure of angle B now in our second triangle is approximately 3.6 degrees. So that we can plug in here. Now we need to find the measure of segment AC to wrap this up. Again, because we have multiple angle measures and multiple side lengths, we can use the law of sines in order to find the measure of segment AC. And if you recall, the law of sines says we take the sine of an angle over the side opposite, set it equal to the sine of another angle over the side opposite that angle. And we said in our first ratio, we want to make sure we're given both the angle measure and the length of the side opposite. So that's why we're going to do sine of angle A over the measure of segment BC, because we're given both of those measurements. That's our first ratio. Then we set that equal to our second ratio, which must include the measure of segment AC. So we're going to do the sine of angle B over the measure of segment AC. Now we just plug in what we know. We know the measure of angle A is 54 degrees. That goes in here. We know the measure of segment BC is 23 kilometers. That goes in here. The measure of angle B we now know is 3.6 degrees. That goes in here. And the measure of segment AC just stays the measure of segment AC, because that's what we're trying to find. We now have a proportion that we're trying to solve for the measure of segment AC. How do we do that? We use the cross product property. We're going to multiply across, set the two products equal to one another, and solve for the measure of segment AC. So to do that, all we have to do is just divide both sides by sine of 54, plug this in our calculator over here, and we get that the measure of segment AC is approximately equal to 1.8 kilometers. So we have now found the missing measurements for triangle ABC in our first triangle and in our second triangle, because the given measurements produce two possible triangles. So we need to find the measurements for both of those triangles, which is what we just did.